Mistake repaired. I replaced the two safety caps I had mounted for two 220 picofarad 1 kilovolt capacitors. In my search for the not so good horizontal alignment of the picture on the Sony screen, I studied the schematic of the video board once again, and I noticed two, or rather three, things that should be looked at more closely. Okay, in my search for the cause of the not so well working horizontal deflection of my Sony, I re-investigated the circuitry for the horizontal deflection, and I noticed, let's say, about 2 or 3 things that were possible causes for the problem I'm encountering. Now, the very first thing I noticed was that, if I can make it focus, that is, okay, so this power transistor here is not connected to its collector, okay, so only its base and emitter are connected, and it seems to me that it's being used as a kind of a power diode, you could say. Now, the thing is that I measured the voltages, and whereas the voltage on the base is pretty close to what it should be, somewhere around 0.65 volts, the voltage on the emitter, which should be, according to the schematic, 0.5 volts or 500 millivolts, I only get something like 20 or 30 millivolts. So that's not so good. Also, the resistor you see here, mentioned here, which should be a 4.7 ohms, is actually more like 7.7 ohms. So if you look at the print board, okay, let me show you. The 2SC140 you see here is actually this one, okay, this little T03 shaped transistor, okay, so this one is that one over there, which is the X21. Now, the 4.7 ohms resistor, which is marked here, is supposed to be this one here. But when I measure this resistor, it measures more like 7.7. So, well, not quite double the value, but, well, way over what what is written on the schematic. So that's not so good. Also, if you look at the back of the print board, you'll notice that indeed the collector pin is not connected at all. You see here, it's not connected, but the case of the transistor is connected, and in fact you can see that right here, this line here. Now, I don't know quite why they would have done that, except perhaps to provide a kind of feedback, you know, as a kind of feedback loop perhaps, but this is a little bit of a mystery to me, why they would use the housing of the transistor and not connect up the collector pin itself. Now, it's quite possible the collector is internally connected to the housing. In that case, I do understand, but my hunch is that the collector pin and the housing will not be connected through. So let's see. Now I broke my camera tripod, and so I'll have to do it like this. Okay, so let me see. Let me set the multimeter to resistance. There you go. Okay, I'm first going to measure it without showing you. Yep, it's connected through. Okay, so you see the multimeter is set to ohms measurement, so let's check. Yep. Okay, so right here is the collector of the transistor. Okay, so and right here is the collector pin. Okay, so if you watch what will measure on the multimeter, if I touch those two pins there, 0 ohms. So excuse me, so in effect they are using the connection to the housing as the collector connection, which, okay, I can understand. It can pull a lot more power than that little pin, but which seems to suggest to me that perhaps that transistor might be becoming hot. I've never touched it while it was in the TV, but perhaps I should and feel whether indeed it gets hot or not. Now, okay, so anyway, the resistor, which is here, and this is supposed to be 4.7, is a 7, well, measures out as 7.7. So I'm going to replace that one. Right, now the next thing that you'll notice is this capacitor here. Now this capacitor, as you can read for yourselves, let me see if I can make a close-up, is a 55 nanofarad capacitor. Now that capacitor is in fact what is represented on the schematic as two separate capacitors mounted in parallel. So these two, a 10 nanofarad and a 40 nanofarad capacitor, or I should say 10 nano and a 40 nano. Now, I suppose they did it this way because back in the day when they were designing the TV, they probably didn't have 50 nanofarad capacitors, so they decided to build a PCB in such a way you could mount a 40 and a 10 nano in parallel. Now it turns out they did not use two capacitors in parallel, but rather one single capacitor, which is this one here, of 55 nanofarad. Now, if you look carefully at the schematic, and you see that the capacitors are tied to ground. If they are leaky, well, if that 155 nanofarad capacitor actually is leaky, quite a bit of power will be pulled to ground, which means that this transistor here, the power transistor, will have to work a lot harder to drive the horizontal deflection coil, because that's what it is going to. So if we follow the line down and down and down, then we follow the line here, then up and then here over that diode here, and then up and up and up the middle line here, yeah, up. You see, it goes to the red wire, and the red wire goes to one of the horizontal deflection coils. Okay, so in other words, if this capacitor here, the 55 nano, is leaky, we have a problem. Okay, so what am I going to do? I'm going to replace that capacitor by a new one, obviously. Now, there's one last thing I noticed. On the same line, which goes to the horizontal deflection coil, there is also mounted one of those blasted IT22 diodes, and which, hang on, let me show you, which is in effect this diode right here. Okay, so this diode here is an IT22 diode. Now, if this diode is bad, then if you follow up, you see there it goes to a 12K resistor, and then it goes to a 100K resistor, and then to a 1 microfarad capacitor. Now, if this diode doesn't work very well, it actually shorts the deflection coil with the brightness circuitry of the TV. So if you follow this line, you follow it up and up and up and up and up, this outer line here, and you go right here, you see it goes up to the brightness button. Okay. So, in other words, if this diode here doesn't work properly, you get a kind of a short between the horizontal deflection and brightness. If this resistor isn't good, then, and the diode isn't good, you get way too much power flowing to ground or to the brightness circuitry. And if this capacitor is leaky, which is a 50 nanofarad, then you get a lot of power drained to ground again. Okay, so these components here, which you see here, these four here, so these two capacitors, the diode and this resistor, or the capacitor here, could all cause quite a bit of trouble in the horizontal deflection. Now, you see, you'll notice here that there should be two capacitors mounted over this diode. Well, at least one should be mounted, say, in sort of parallel with the diode and that other capacitor here. Now, I'm not directly finding this one, but I do find this one, and I do find the diode. Now, my hunch is that the 50 nanofarad you see here, okay, this 15 nanofarad is this one here, this brown one here. Only the problem is I can't read its value. So I'll have to look it up whether this is in fact the 15 nano I'm looking for. However, the other one, the 50 nanofarad capacitor, which you see here, is in fact this one here, this green one here. So I will need to replace this one. So okay, so and there you have the diode here. Okay, now like I said, on the schematic it says that the resistor you see here is a 12K. Okay, and oh, by the way, you see 5%, so it should be within 5% tolerance. Now the weird thing is that the resistor which is mounted here, which is this one here, is a 10K. So if you look closely, you see I'm trying to give you a good view on it. Okay, you see it's brown, black, orange. Okay, so that's a 10K, not a 12K. So that's a bit of a mystery to me as well. I'm tempted to replace it and to put in a 12K like the schematic calls for. Right, so I have quite a few parts to replace, but what I'll replace first of all is this capacitor here, this 55 nanofarad one, and I'm going to replace this. Well, these two 50 nanofarad ones I'm going to replace, and then I'm going to replace this resistor probably for a 4.7 instead of a 7.7. Now I'm not going to replace immediately this transistor because I want to see whether this transistor here, I'm not going to replace it immediately because I want to see whether changing this resistor will pull up the voltage, which I should measure right here. Okay, so I should be able to measure around 500 millivolts and not 20 or 30. So if I replace this transistor, this resistor, which is now on a PCB, to a 4.7, then maybe I will be able to measure a much higher voltage at the emitter here. Now you'll notice a small star symbol, an asterisk symbol here. Now this simply means that this part is not mounted in all models of the 5303 Sony TV. But in mine there is a resistor, only not a 4.7 but a 7.7. It's a bit weird. I mean, it's a TO3 transistor, so normally a TO3 transistor doesn't have a collector pin. It only has a housing and 2 pins for the base and the emitter. Weird, but okay, I suppose back then they built that kind of power transistor. Anyway, I'm going to replace the 2SC140 transistor, which is an NPN by the way, by this little thing here. Now this is a BD139. It's also an NPN transistor and it has pretty closely matching characteristics. But there's a problem. The original transistor, as you can tell here, has a small TO3 housing. Okay, so this is the normal TO3 size. This one is a miniature size. But you can see immediately that the shape of the TO3 is completely different from the shape of the replacement transistor, okay? This is called the TO126 housing. It's not much bigger than the one I'm going to replace, but the housing is completely different. So that will pose somewhat of a challenge to me to mount this in a place of this. But I'm up to it, and every new challenge is something new to learn. So, oh yeah, I meant to say also that the transistor is actually used as a regular transistor, okay? It's not used like a power diode or anything like that. It is actually connected the way a transistor should be connected. Now, I'm not entirely sure how you would call this kind of setup, but it reminds me of a Darlington setup. So a small driver transistor that amplifies the driving signal to drive a power transistor, okay? So this setup looks suspiciously like a Darlington setup. Now I need to refresh my memory whether this is in effect a Darlington setup, and I'll get back to it once I've read up on it. Alright, I replaced the little 2SB140 power transistor, and now the mystery as to why it has 3 pins below and not 2 is finally revealed. Those Japanese found a nice trick actually of pressing a TO5 transistor into a kind of a TO3 housing, and that's why it has 3 pins actually, instead of the classical TO3 with only 2 pins, namely the base and the emitter, and then the collector being the housing. So yeah, actually good trick. So anyway, I replaced this transistor with a BD139, and I don't know if you can see it, but there it is. Okay, so what I did was I actually wrapped it in a little bit of aluminum paper to provide for good contact to the screw which is holding it down to the print board, and you can see the screw over there. Okay, so it works. The BD139 was indeed a good alternative to the 2SB1, or excuse me, the 2SC140. Now, just to show you the voltages, I'm going to measure it with my multimeter. Okay, so let me switch it on. Okay, where is the measuring pin? There it is. Okay, so let's measure this pin first. Okay, so this is the base pin, and it now measures 1.14 volts. Okay, now let's measure the emitter. The emitter is connected to this, and now it measures 600, say 680 or 690 millivolts. Okay, so 1.1 and 680 millivolts. Okay, now the schematic says that the voltages should be 0.7 and 0.5. So that's not entirely the same voltages, but basically the picture is good. Okay, so it's a really good picture. Now I did manage to make the sound work, and it buzzes. I think you can hear the buzzing, but I can't get the sound signal to come through. No matter how many times I try, no matter which channel I try, I just don't seem to be getting sound. So that seems to suggest to me that the tuner is okay, but that the connection between the tuner and the amplification stage of the TV is somewhere interrupted, perhaps, or broken. So I'll need to check on that. When I get the sound done, well, then the chassis is ready to be mounted back into its cabinet. The cabinet I painted last week. I unmounted the CRT from the Sony. Unfortunately, to be able to handle the CRT without having to carry out the whole chassis, I had to cut loose 3 wires. And those 3 wires are for the yoke. In fact, the blue and the red are for the horizontal yoke, and the yellow and red striped and green one are for the vertical deflection yoke. Now, anyway, what I'm going to do is to tape off the whole screen with special painter's tape, which is tape that doesn't damage underlying paint or anything, but also doesn't let through paint. Now I am in the process of covering up the screen front, but I'm also going to cover up the anode of the screen with a little round cover, which I will tape to the CRT, and then I will neatly cut the tape in a circular pattern. Once that is done, I'll cover up the neck of the CRT in a small plastic bag, which I will tape shut. And when that is done, then I'm going to remove the old aquadag which is on the CRT as much as I can. And I'm going to tape off the original stamp, let's say, or sticker on the CRT. And once that is all protected and packed in, and the old aquadag is removed, then I will apply a new layer of aquadag. I think I found the right product to do it, but I'm afraid there's only one way to test it, and that's by actually doing it. So here we go.